One of the representational tools we're going to use when we look at energy and energy transfer are energy bar graphs and flow diagrams. And these are also called LOL diagrams, and I'll leave it to you to figure out why they're called that. These are going to help you perform quantitative analysis of the energy flow during a change. So the initial energy state of the system is represented with a bar graph, as you can see here, and that shows you how much energy is stored in each storage mode, so kinetic, gravitational, and so on. To the right of this bar graph here, this is called an energy flow diagram, and it indicates which objects are inside the system and which objects are outside the system. So in this case, Biff, the Earth, and the balloon are inside the system, but Buffy is outside the system. And it also shows whether energy is transferred into or out of the system by working or heating or some other process, which is given by this kind of arrow here. And the arrow is also kind of quantitative. It shows that there are two amounts or blocks of energy compared to the 5 that were there originally. And then on the far right here, we've got another bar graph which indicates that final distribution of energy in that system. So to use this kind of representation for a quantitative analysis, you can write also a mathematical expression which shows what energy storage modes or what transfer methods are involved in this process here. So we've got gravitational plus the work equals the final kinetic, gravitational, and internal energy of the system here. So it essentially shows that the sum of the initial storage modes plus or minus any energy flowing into or out of the system equals the final storage modes. So we're just going to consider as an example this situation here where Buffy is throwing a water balloon and it lands on Biff's head there. So in this case, the system, as I said before, contains Biff, the Earth, and the balloon, but it doesn't contain Buffy. The zero position for the gravitational potential energy is the floor that Biff is standing on, so it's down here. So that balloon starts off with a reasonable amount of gravitational potential energy because it's up above that 0 point. Now Buffy is an external agent. He or she is not in the system, and let's say she, for the sake of argument, applies a force through some distance to the balloon which sends it in motion. And so this, because it's applying a force that causes a displacement, this is called working, so it's adding energy to the system. Right, and you can see that here. The energy has been added to the system by working. Okay, in the final state, the moving balloon and the water have some kinetic energy, so they've been splashed around or broken and bits are flying everywhere. The Earth balloon system still has some gravitational energy because it hasn't hit the floor. Remember, the floor was the Biff is standing on as the 0 point, so it still has some potential energy left. And some of the energy ends up in the internal account because of the increases in the internal energy of the inside the water, inside Biff's head, and so on. So and the balloon scraps. Now, if Buffy had been included in the system to start with, then we would have needed a separate account here for the chemical energy that's stored in Buffy, and Buffy would use that chemical energy to convert it into the motion of the balloon. So there wouldn't be any work done on the system, it would all be internal energy transfer. And we'll be doing some more examples using these types of bar graphs and flow diagrams to analyse energy transfer